May 27, 1942, Pearl Harbor, Hawaii. The morning sun cast long shadows across the harbor as black smoke billowed from the wounded USS Yorktown's stack. Her flight deck bore the scars of Japanese bombs, twisted steel plates, gaping holes, and the acrid smell of burned aviation fuel hanging heavy in the humid air. Behind her, a 10-mile oil slick marked her painful journey home from the Coral Sea. In radio intercept stations across the Pacific, Japanese naval intelligence officers carefully logged another victory. Carrier CV-5, they noted with satisfaction, had been struck multiple times by Imperial Navy bombers. The damage appeared catastrophic. By their calculations, based on their own repair capabilities, such a vessel would require months in dry dock, if she could be saved at all. 3,000 miles away in Tokyo, Admiral Yamamoto's staff crossed the Yorktown off their operational assessments, one less American carrier to worry about. The mathematics of the coming battle at Midway suddenly looked more favorable. They had no idea they were about to witness something that would shatter every assumption about American industrial might, something that would change the course of the Pacific War in just 72 hours. The Battle of the Coral Sea had ended just 19 days earlier, marking the first naval engagement in history where opposing fleets never saw each other. Both sides claimed victory, but the brutal mathematics of carrier warfare told a different story. The Japanese had lost the light carrier Shoho and suffered severe damage to their fleet carrier Shokaku. More critically, they had lost experienced pilots and aircrew, irreplaceable assets in the vast Pacific theater. For the Americans, the price seemed even steeper. The USS Lexington, one of only 4 fleet carriers in the Pacific, lay at the bottom of the Coral Sea after internal explosions ripped it apart. The Yorktown had taken a direct hit from a 250-kilogram bomb that penetrated 4 decks, damaged boilers, and left her listing to port. Her captain, Elliot Buckmaster, had managed to restore level trim, but the carrier's maximum speed dropped to just 24 knots, barely enough to launch aircraft in calm seas. As Yorktown limped toward Pearl Harbor, her crew worked frantically on temporary repairs. They welded steel plates over the worst holes, jury-rigged damaged systems, and constantly pumped out compartments taking on water. The ship's radio operators transmitted detailed damage reports to Pearl Harbor, each message monitored by Japanese listening posts scattered across the Pacific. Japanese naval intelligence had developed sophisticated methods for tracking Allied ship movements and damage assessments. Their codebreakers, while not as successful as their American counterparts, had cracked enough traffic to understand general fleet dispositions. When they intercepted reports of Yorktown's severe damage and slow speed, their analysis seemed straightforward. A carrier with that level of structural damage would require extensive dry dock time, at least 3 months by Japanese standards. This assessment carried enormous strategic weight. Admiral Yamamoto was planning Operation MI, the assault on Midway Atoll designed to lure the remaining American carriers into a decisive battle. Intelligence estimates suggested the Americans had only 2 operational fleet carriers in the Pacific, Enterprise and Hornet. Both were part of Task Force 16 under Admiral William Halsey, but Halsey himself was hospitalized with a severe skin condition, replaced by the relatively unknown Rear Admiral Raymond Spruance. The Japanese plan hinged on numerical superiority. Yamamoto would bring 4 fleet carriers, Akagi, Kaga, Hiryu, and Soryu, plus supporting battleships and cruise ers. Against 2 American carriers, the odds seemed overwhelming. The loss of Lexington and the presumed long-term damage to Yorktown had shifted the carrier balance decisively in Japan's favor. What the Japanese intelligence officers didn't understand was the industrial revolution taking place in American shipyards and repair facilities. While they calculated repair times based on their own limited dry dock capacity and conservative engineering practices, the Americans were rewriting the rules of naval maintenance and damage control. Pearl Harbor had become more than a naval base. It had transformed into an industrial complex that rivaled anything on the mainland United States. The December 7th attack had taught harsh lessons about vulnerability, but it had also demonstrated American capacity for rapid recovery and innovation. The transformation of Pearl Harbor into an industrial powerhouse began in the smoke and chaos of December 7, 1941. As rescue teams pulled sailors from the water and firefighters battled blazes on Battleship Row, A quieter revolution was already beginning. Captain Homer Wallen, the battle force engineer, looked at the devastation and saw not just destruction, but opportunity. The sunken battleships could be raised, the damaged vessels could be repaired. Most importantly, America could build a repair capability that would astound the world. Within weeks of the attack, Pearl Harbor buzzed with activity that had nothing to do with combat operations. Floating dry docks arrived from the West Coast, towed by powerful ocean-going tugs. Machine shops that normally serviced destroyers expanded to handle battleship-sized repairs. Most revolutionary were the repair ships, vessels designed to bring heavy industrial capability directly to the fleet. USS Vestal, damaged but not destroyed at Pearl Harbor, became the prototype for a new kind of warfare support. Unlike traditional repair ships that could handle only minor maintenance, Vestal carried machine shops capable of manufacturing replacement parts, welding equipment that could repair hull damage, and skilled technicians who could rebuild complex mechanical systems. Her crew had learned to work miracles with limited resources, fabricating parts that would normally require major shipyard facilities. The American approach to naval repair reflected a fundamental difference in industrial philosophy, where Japanese naval doctrine emphasized careful, methodical repairs using precise specifications and traditional methods. American engineers embraced improvisation and speed. They developed new welding techniques that could be performed underwater. They created modular replacement systems that allowed rapid swapping of damaged components. Most importantly, they trained ordinary sailors to perform repairs that Japanese doctrine reserved for specialized shipyard workers. Service Squadron 10, established in September 1943, would eventually demonstrate the full potential of mobile repair capability. But even in early 1942, the foundations were being laid. Floating dry docks capable of lifting entire battleships were positioned throughout the Pacific. Repair ships carried machine shops that could manufacture anything from propeller shafts to fire control systems. Most remarkably, these facilities were mobile. They could move with the fleet, bringing industrial capability directly to the combat zone. The Japanese had nothing comparable. Their repair doctrine relied on fixed bases with permanent dry docks and extensive shore facilities. Damaged ships had to return to major ports like Yokosuka or Kure, journeys that could take weeks and remove vessels from combat for months. Their repair ships were essentially floating workshops capable of minor maintenance, not the industrial powerhouses the Americans were developing. This difference reflected broader cultural and economic factors. American industry had embraced mass production techniques that emphasized speed and standardization. Factory workers were trained to be flexible, capable of switching between different tasks as production demands changed. This industrial culture translated directly to naval repair, where speed and adaptability mattered more than perfect craftsmanship. Japanese industrial culture, by contrast, emphasized precision and traditional methods. Their shipyard workers were highly skilled craftsmen who took pride in perfect work, but this approach required time and extensive facilities. The concept of rapid field repairs using improvised methods was foreign to their engineering philosophy. As Yorktown approached Pearl Harbor trailing her oil slick, these two philosophies were about to collide in the most dramatic way possible. Japanese intelligence officers, calculating repair times based on their own methodical approach, could not imagine what American industrial ingenuity was about to accomplish. The human angle of this story begins with the men who would perform the impossible. As Yorktown's anchor chains rattled into Pearl Harbor's waters, dock workers were already assembling on the pier. These weren't military personnel. They were civilian shipyard workers, many of them Hawaiian residents who had watched their home burn on December 7th. For them, every day was personal revenge against the Japanese Empire. Among them stood men like Chief Shipfitter Joseph Hartley, whose hands bore the scars of 6 months working on damaged battleships. Hartley had learned to read metal fatigue the way doctors read X-rays, understanding instantly which repairs were essential and which could wait. His crew of welders and metalworkers had developed their own shorthand, a rapid communication system that let them coordinate complex repairs without wasting precious minutes on lengthy explanations. The technical innovation angle reveals how American engineers were rewriting the rules of ship repair. Traditional naval architecture assumed that major structural damage required complete replacement of damaged sections, a process that involved careful removal of rivets, precise measurement of replacement plates, and methodical installation that could take weeks. American repair crews had developed a revolutionary approach. Instead of replacing, they reinforced. Using new welding techniques and high-strength steel patches, they could restore structural integrity in hours rather than weeks. The key insight was that combat repairs didn't need to restore original specifications. They just needed to make the ship seaworthy and combat-capable. A patched flight deck might not look pretty, but if it could launch and recover aircraft, it accomplished the mission. The Japanese intelligence angle exposes a fundamental failure in enemy assessment capabilities. Japanese naval intelligence operated under the assumption that American repair capabilities matched their own. When they calculated 3 months for Yorktown's repairs, they based this estimate on how long similar damage would take in Japanese facilities. This wasn't just a technical miscalculation, it was a cultural blind spot. Japanese military culture emphasized thorough, methodical approaches to complex problems. Their repair doctrine required extensive analysis, detailed planning, and careful execution. The idea that Americans might skip these steps and dive directly into rapid repairs seemed reckless and unprofessional. They couldn't conceive that such an approach might actually work. This cultural misunderstanding extended to broader Japanese assumptions about American character. Many Japanese leaders viewed Americans as soft, indisciplined, and lacking the spiritual dedication necessary for total war. The idea that American workers might voluntarily work around the clock, skip meals, and push themselves to physical exhaustion seemed incompatible with their stereotypes of American materialism and comfort-seeking. From Admiral Yamamoto's headquarters in Tokyo, the intelligence reports seemed to confirm existing assumptions. Yorktown would be out of action for months, leaving the Americans with only 2 operational carriers. The coming battle at Midway would achieve the decisive victory that would force America to negotiate peace. Every calculation supported this conclusion, except the calculations were based on completely wrong assumptions about American capabilities. The strategic implications were staggering. Japanese war planning for 1942 assumed they had a narrow window of opportunity before American industrial production began affecting the naval balance. If this could destroy the remaining American carriers in one decisive battle, they could establish a defensive perimeter that would be too costly for Americans to penetrate. The temporary loss of Yorktown seemed to make this strategy feasible. The leadership decisions angle illuminates the remarkable command structure that made the miracle possible. Admiral Chester Nimitz, Commander-in-Chief of the Pacific Fleet, had already demonstrated his willingness to take calculated risks. When intelligence intercepts revealed Japanese plans to attack Midway, Nimitz faced an agonizing choice. He could wait for Yorktown's repairs to be completed properly, or he could gamble everything on getting her seaworthy in time for the battle. The decision required Nimitz to override standard naval procedure and his own engineering advisors. Navy regulations specified minimum repair standards for carriers returning to combat. Yorktown's damage was severe enough that regulations would normally require at least 2 weeks in dry dock, followed by extensive sea trials to verify all systems. Nimitz compressed this timeline to 72 hours with no sea trials, a decision that could have resulted in the loss of the carrier and her entire crew if the repairs failed. Captain Elliot Buckmaster, Yorktown's commanding officer, faced an equally difficult decision. He had to trust that civilian workers could accomplish in 3 days what naval doctrine said required 3 months. More challenging, he had to maintain crew morale while acknowledging that they were sailing into battle aboard a ship held together by welds and prayers. Buckmaster's solution was radical transparency. He told his crew exactly what they were attempting and why it mattered. The industrial capacity angle reveals the true scope of American wartime mobilization. Pearl Harbor in May 1942 operated at an intensity that would have been unimaginable before the war. The Navy Yard worked 3 shifts around the clock, with workers sleeping in shifts on cots set up in administrative buildings. Supply lines stretched back to the mainland, bringing specialized equipment and materials by high-priority air transport when necessary. The scale of resources dedicated to Yorktown's repair was staggering. Over 1,400 workers swarmed over the carrier during her 3 days in dry dock, They consumed more than 20 tons of steel plate, 5 miles of welding rod, and countless specialized components. Machine shops that normally produce small parts for destroyers were retooled overnight to fabricate replacement sections for flight deck structure. This industrial surge wasn't just about Yorktown. It represented a fundamental transformation in how America approached naval warfare. The traditional model assumed that damaged ships would return to established shipyards for repair. The new model brought shipyard capability directly to the combat zone, using repair ships, floating dry docks, and mobile workshops that could deploy anywhere in the Pacific. The broader strategic context reveals how completely the Japanese had misunderstood their enemy. While Japanese planners focused on tactical victories and decisive battles, Americans were building an industrial infrastructure that could sustain prolonged warfare. Every repair ship launched, every floating dry dock completed, and every mobile workshop deployed represented American commitment to a war of attrition that Japan could not win. The floating repair capabilities that emerged during 1942 would eventually become Service Squadron 10, a naval formation larger than most entire fleets. These vessels could perform major repairs while anchored in remote atolls thousands of miles from the nearest permanent base. By 1944, American carriers could remain in combat for months without returning to port, supported by a mobile industrial infrastructure that followed them across the Pacific. Japanese naval leadership, trained in the tradition of decisive battle and quick victory, could not adapt to this new reality. Their strategic planning assumed that damaged ships would be out of action for months, that industrial capacity was fixed at pre-war levels, and that American civilian workers lacked the dedication necessary for total war. Every assumption proved catastrophically wrong, and nowhere was this more dramatically demonstrated than in the 72 hours that Yorktown spent in Pearl Harbor's Dry Dock No. 1. At exactly 0800 hours on May 28, 1942, massive pumps began draining water from Dry Dock No. 1. As the water level dropped, the full extent of Yorktown's damage became visible for the first time since the Coral Sea Battle. The sight that greeted Chief Constructor William Wilson was enough to make experienced shipwrights pause in shock. The Japanese bomb had penetrated the flight deck and exploded deep within the ship's structure, creating a jagged hole that extended through 4 decks. Twisted steel beams hung at impossible angles, electrical cables dangled like severed arteries, and the acrid smell of burned insulation filled the morning air. Water damage extended far beyond the immediate blast area, as ruptured pipes had flooded compartments throughout the forward section of the ship. Wilson had 40 years of naval construction experience, including work on the original carriers Lexington and Saratoga. By every standard he knew, this level of damage required at least 6 weeks of careful reconstruction. Admiral Nimitz had given him 72 hours. The civilian workforce that descended into the dry dock represented something unprecedented in naval history. These weren't just shipyard workers. They were the best repair specialists on the West Coast, many flown in specifically for this job. Master welder Tommy Nakamura had worked on the Golden Gate Bridge before the war. Steel fabricator Mike O'Brien had helped build Liberty ships in record time. Electrical technician Sarah Martinez was one of the first women certified for military vessel work. Working under banks of floodlights that turned night into day, the crews attacked Yorktown's wounds with systematic fury. The first priority was structural integrity, ensuring the ship could survive the stresses of high-speed maneuvering and potential combat damage. Traditional repair doctrine would have required removing all damaged steel and replacing it with new sections cut to exact specifications. The Pearl Harbor teams took a radically different approach. Instead of replacement, they chose reinforcement. Heavy steel plates were welded directly over damaged areas, creating a double hull effect that was actually stronger than the original construction. Where traditional repairs would have required precise measurement and custom fabrication, the emergency teams used standard plates and shaped them with cutting torches and power hammers. The welding work alone represented a technical marvel. Naval regulations specified detailed procedures for welding on warships, including specific rod compositions, precise heat treatments, and mandatory stress relief procedures. The emergency crews abandoned these time-consuming protocols in favor of continuous welding using new high-strength rods that could create battlefield-ready joints in a fraction of the normal time. Electrical repairs presented an even greater challenge. The bomb explosion had severed primary power cables and damaged complex fire control systems that normally required factory repair. Yorktown's electrical officer, Lieutenant Commander George Davis, made a crucial decision that violated standard procedure. Instead of attempting to restore the original complex routing, his teams installed simplified bypass systems that would provide basic functionality. The flight deck reconstruction pushed improvisation to its limits. The bomb hole had destroyed not just the wooden planking, but the underlying steel structure that supported aircraft operations. Traditional repairs would have required removing a large section of flight deck and rebuilding it from the framework up. The Pearl Harbor solution was audacious in its simplicity. They welded a thick steel plate directly over the damaged area and covered it with new wooden planking. This repair wouldn't pass peacetime inspection standards, but it would support aircraft operations. More importantly, it could be completed in hours rather than weeks. As the steel plate was lowered into position by the dry dock's massive cranes, Japanese intelligence officers monitoring radio traffic had no idea they were witnessing the birth of a new approach to naval warfare. The pace of work defied everything the Japanese knew about Western industrial practices. American workers were supposed to be clock watchers, consignes, and more with union rules than military necessity. Instead, Pearl Harbor's repair crews worked 18-hour shifts without complaint, sleeping on the job site and eating meals brought by volunteers from Honolulu's civilian community. By the morning of May 30th, Yorktown looked like a ship reborn. The massive hole in her flight deck was covered by fresh planking. Her stack, painted in regulation gray, showed no signs of the internal damage that had nearly caused her loss at Coral Sea. Most remarkably, her hull gleamed with new steel patches that were actually stronger than the original construction. At 0900 hours, Admiral Nimitz climbed aboard for a personal inspection. What he found would have made peacetime naval inspectors horrified, but it impressed the Pacific Fleet commander enormously. The repairs were crude, improvised, and utterly functional. Every system needed for combat operations had been restored or replaced. Anything non-essential had been ignored or temporarily bypassed. Captain Buckmaster presented his damage control report with characteristic honesty. The carrier was seaworthy and combat capable, but she remained wounded. Her maximum speed was still limited to 27 knots. Some secondary systems remained offline. Most critically, the improvised repairs might not survive sustained combat damage. Buckmaster recommended limiting Yorktown to defensive operations until proper repairs could be completed. Nimitz listened to the report, then delivered one of the most consequential orders of the Pacific War. Yorktown would sail immediately for Midway, arriving just in time to join Enterprise and Hornet in Task Force 17. She would not be held in reserve. She would participate fully in whatever battle awaited. The decision represented the ultimate gamble on American industrial improvisation. As Yorktown cleared Pearl Harbor on the afternoon of May 30th, trailing no oil slick this time, Japanese radio intercept stations detected unusual activity. The carrier's radio signature was unmistakable, but the traffic patterns suggested she was heading northwest toward the Central Pacific rather than south toward the West Coast repair facilities. This made no sense according to Japanese damage assessments. The first reports reached Admiral Nagumo's flagship Akagi as the Kido Butai, Japan's premier carrier strike force, approached Midway from the northwest. Intelligence officers aboard the flagship studied the intercepts with growing confusion. Either American radio discipline had completely collapsed, allowing a heavily damaged carrier to break radio silence, or their damage assessments had been catastrophically wrong. On June 4, 1942, at 1005 hours, Lieutenant Commander Wade McCluskey's dive bombers from Enterprise spotted the Japanese carrier formation. As his SBD Dauntlesses rolled into their attack dives, McCluskey had no idea he was about to provide the answer to Japanese intelligence confusion in the most dramatic way possible. The attack that followed represented one of the most perfectly coordinated strikes in naval aviation history. Enterprise and Hornet's dive bombers hit Akagi, Kaga, and Soryu in rapid succession, turning all three carriers into flaming wreckage within minutes. But it was the fourth carrier, Hiryu, that would provide the most shocking revelation to Japanese commanders. Hiryu's counterattack targeted the American carriers with deadly precision. Her dive bombers, led by Lieutenant Michio Kobayashi, found Yorktown operating at full combat capability despite intelligence reports that she should have been in a West Coast shipyard. The sight of the supposedly crippled carrier launching and recovering aircraft at full operational tempo sent shockwaves through the Japanese command structure. When Hiryu's bombers scored 3 direct hits on Yorktown, Japanese observers expected to see the immediate effects of attacking an already weakened vessel. Instead, they watched in amazement as the carrier absorbed the damage, controlled flooding and fires, and continued flight operations. The emergency repairs performed at Pearl Harbor had actually made portions of the ship more resistant to battle damage than original construction. Admiral Nagumo, watching the battle from his burning flagship, finally understood the magnitude of Japanese miscalculation. The Americans hadn't just repaired Yorktown, they had demonstrated an industrial capability that made traditional damage assessments meaningless. If the Americans could restore a heavily damaged carrier to full combat capability in 72 hours, what did that mean for Japanese hopes of winning a war of attrition? The revelation came too late to affect the Battle of Midway, but its implications would haunt Japanese strategic planning for the remainder of the war. As Hiryu's aircraft pressed their attack on Yorktown, both sides were learning that the rules of naval warfare had fundamentally changed. American industrial improvisation had created capabilities that Japanese military doctrine couldn't comprehend or counter. The news reached Tokyo at 0300 hours on June 5, 1942, delivered by a grim-faced communications officer to Admiral Yamamoto aboard the battleship Yamato. 4 fleet carriers lost. The cream of Japanese naval aviation destroyed. Most shocking of all, the supposedly crippled Yorktown had not only participated in the battle, but had required concentrated attacks from 2 separate airstrikes to finally sink her. In the Imperial Navy's intelligence centers, staff officers frantically reviewed their damage assessments from the Coral Sea battle. The mathematics seemed impossible. How could a carrier that suffered major structural damage return to combat in less than 3 weeks? Their own experience suggested such repairs required months in major shipyard facilities. Either their damage assessment had been completely wrong, or American repair capabilities exceeded their wildest estimates. Captain Kamito Kuroshima, Yamamoto's chief planning officer, spent the day after Midway reviewing intelligence files with growing alarm. The pattern was becoming clear. American ships that Japanese intelligence had written off as heavily damaged were returning to combat in impossibly short time frames. USS Maryland, severely damaged at Pearl Harbor, had returned to action within months. USS Pennsylvania, also hit on December 7th, was already back in service. Most disturbing, these repaired vessels often performed better than before their damage. The revelation forced a complete reassessment of Japanese strategic assumptions. War Plan Orange had assumed that damaged American vessels would be out of action for extended periods, gradually reducing the size of the Pacific Fleet through attrition. If Americans could repair major damage in weeks rather than months, the entire foundation of Japanese strategy crumbled. Admiral Ugaki, Yamamoto's chief of staff, ordered an immediate review of America and industrial intelligence. What they discovered should have been available months earlier, but Japanese military culture had dismissed civilian industrial capability as irrelevant to naval warfare. American shipyards were launching new vessels at unprecedented rates while simultaneously developing mobile repair capabilities that could restore damaged ships anywhere in the Pacific. The floating dry dock program alone represented industrial capacity that Japan could not match. American industry was producing these massive structures at rates that suggested unlimited resources and manufacturing capability. More threatening, these dry docks were being deployed throughout the Pacific, creating repair infrastructure that moved with the advancing American fleet. Japanese repair doctrine based on fixed facilities and methodical procedures could not adapt to this new reality. Their major naval bases at Truk, Rabaul, and other forward positions lacked the industrial infrastructure to perform major repairs. Damaged Japanese vessels had to return to home waters, journeys that often took longer than American complete repair cycles. The psychological impact on Japanese naval leadership was devastating. The carefully calculated timetables that had driven their early war strategy suddenly seemed meaningless. If American carriers could be repaired in days rather than months, how could Japan maintain the numerical superiority that their strategy required? By late 1942, American floating repair capabilities had evolved into something that would have seemed like science fiction to pre-war naval planners. Service Squadron 10, officially established in September 1943, represented the culmination of lessons learned from Yorktown's emergency repair. The squadron eventually grew to more than 600 vessels, creating mobile industrial infrastructure that could support sustained combat operations thousands of miles from permanent bases. The psychological warfare aspect of rapid American repairs became apparent as Japanese intelligence struggled to track damage and recovery cycles. Ships that should have been out of action for months appeared in combat reports within weeks. The uncertainty began affecting Japanese tactical planning, as commanders could no longer rely on damage assessments to predict enemy capabilities. USS New Orleans provided perhaps the most dramatic example of American repair innovation. After losing her entire bow to a Japanese torpedo at Tassafaronga in November 1942, the cruiser should have been a total loss. Instead, repair crews fitted her with a temporary bow made of coconut logs and steel plates, allowing her to steam backwards 5,000 miles to Puget Sound for proper repairs. The image of a major warship sailing stern first across the Pacific became a symbol of American determination and ingenuity. The strategic implications extended far beyond individual ship repairs. American industrial capacity was creating sustainable combat power that could operate indefinitely in forward areas. Japanese strategy had assumed that extended supply lines would limit American offensive capability. Instead, mobile repair infrastructure made American fleets more independent of fixed bases than Japanese forces. The floating dry dock program reached full effectiveness by 1944, when massive structures capable of lifting entire battleships were operating in forward areas throughout the Pacific. These installations could perform repairs that previously required major shipyard facilities, allowing damaged vessels to return to combat without the long journey to West Coast yards. Japanese naval planning never successfully adapted to this new reality. Their intelligence services continued to use traditional damage assessment methods, consistently overestimating American repair times and underestimating fleet availability. This intelligence failure contributed to strategic miscalculations throughout the remainder of the Pacific War. The human cost of Japanese miscalculation became apparent in battles like the Philippine Sea, where American task forces operated continuously for months without returning to port. Japanese pilots, already facing increasingly desperate odds, found themselves confronting enemy fleets that seemed to repair damage faster than it could be inflicted. The Industrial Revolution that began with Yorktown's 72-hour repair ultimately produced American naval capabilities that Japanese planners had never imagined possible. Mobile repair infrastructure, floating dry docks, and improvised engineering techniques created sustainable combat power that could operate anywhere in the Pacific. Japanese admirals who had laughed at American industrial claims in 1941 found themselves facing the reality of those capabilities by 1944. The 72 hours that Yorktown spent in Pearl Harbor's Dry Dock No. 1 represented more than emergency ship repair. They marked the moment when American industrial culture fully adapted to naval warfare. The Japanese had planned for a war against the American fleet of 1941. Instead, they found themselves fighting an enemy that could transform industrial capacity into combat power faster than they could sink it. The laughter of Japanese admirals in early 1942 reflected a fundamental misunderstanding of their enemy's character. They had assumed that American materialism and comfort-seeking would translate into military weakness. Instead, those same qualities, improvisation, resource mobilization, and pragmatic problem-solving, became decisive advantages in sustained naval warfare. Yorktown's story illuminates a broader truth about warfare in the industrial age. Victory no longer belonged to the side with the most elegant tactics or the most heroic individual efforts. Victory belonged to the side that could most effectively transform civilian industrial capacity into military power. The crude steel patches welded onto Yorktown's hull represented the same industrial philosophy that would ultimately produce victory in the Pacific. The Japanese never developed an effective counter to American repair capabilities because they never fully understood what they were facing. Their military culture emphasized perfection and methodical procedures, qualities that served them well in peacetime but proved inadequate for the improvisational demands of total war. American willingness to accept good enough solutions that could be implemented quickly proved superior to Japanese insistence on perfect solutions that required months to complete. The floating repair ships and mobile dry docks that emerged from the Yorktown experience would eventually enable American naval forces to operate continuously for years without returning to home ports. This capability, unimaginable in 1941, became the foundation of American victory in the Pacific. The admirals who had laughed at American industrial claims learned too late that they had underestimated not just American capacity, but American character itself.